Here we're asked to calculate the derivative of f over g at 1, given a table of values for f of x and f prime of x, g of x, g prime of x at various values of x. So recall that f over g prime of x, which is the derivative of f of x over g of x with respect to x, is g of x times f prime x minus f of x times g prime of x all over g of x quantity squared. And this is the quotient rule. And we'd like to evaluate this at x equals 1. So this is g of 1 times f prime of 1 minus f of 1 times g prime of 1 all over g of 1 squared. Now we have limited information in our table, but we have enough to fill in these values. So we see here that g of 1 is 2, f prime of 1 is 1, f of 1 is negative 1, g prime of 1 is negative 2, and we divide by g of 1 squared, which is 2 squared. So this is equal to 2 minus 2 over 4, which is 0. Now the second part asks us to calculate f after g prime of 2, and for this we must remember the chain rule. So f after g is f of g of x, and we know that f after g prime of x, which is the derivative with respect to x of f of g of x, is equal to f prime applied to g of x, what's inside the brackets, times the derivative of what's inside the brackets, which is g prime of x. And we'd like to evaluate this at x equals 2. So f after g prime of 2, filling in 2 for x, is f prime applied to g of 2 times g prime of 2. Now, using our table, we see that g of 2 is equal to 1. Sorry, we have g of 2 equals 1. So we're looking at f prime of 1 times g prime of 2, which is negative 1. Now we need to evaluate f prime of 1, and we see from our table that f prime of 1 is 1, so this is equal to 1 times negative 1, which is negative 1. So we have f after g prime of 2 is negative 1.